Hello everyone. So in today's video, we are going to take a look at Amazon Simple Queue service. We are going to take a look at how to create the queues on AWS portal or the AWS console. And then we are going to take a look at a small Express JS application in which we are going to use Simple Queue service to put messages into queue and to get messages from the queue. Simple Queue service to get started with is a fully managed service from Amazon, and it provides us some queues. We can create some queues in which sending and receiving applications can put and get messages from. So it helps us to create microservices based applications, distributed system, and it is also providing a serverless application. As we can see, it is fully managed and it is serverless. So we do not have to care about provisioning servers and scaling up or scaling down or anything. So it has a few use cases. It is managed, fully managed by AWS, so it is reliable and it provides us security. It is cost effective as well, and we do not have any sort of overhead on it. So what happens with these sort of queue services, let's move to a diagram. So when we have two applications which are sending and receiving some data, or when we have a single application which is based on microservices, but and what do microservices means? Microservices, the application is broken down into smaller chunks based on like what task they perform. For example, if there is some task to place the order and then to inform the user on notifying them that their order is placed, so we can notify them using emails. So what happens is that when the order is placed, our one microservices is taking care of placing the order, and the other is sending email, right, to notify the user. So email sending is a process which takes a few seconds to, like, whether the email is delivered to the user or not. All of these applications, the backend, are stored on the SMTP server, which is sending the email or not. So I'm not going to be a lot technical here, but sending emails can delay the process, and two applications can be decoupled based on what specific task they are performing. So in the backend, if we are using an e-commerce platform, we can place orders and we can have higher or large number of servers for placing the orders and less number of servers for sending emails. So they both the application, like notification mechanism and placing the order mechanism, can scale independently if we are using something like a queue between them. So what happens, like when an order is placed, the sending application or whatever application it is, the order application will place the message in the queue for the notification mechanism to read the message from the queue whenever the notification mechanism application is free enough or has less load to process new emails. So it will read the message from the queue and send the email to the user and delete that message. So that is how the queue works. So let's see how to create a queue first, and then we will take a look at our Express.js example. So I have my simple queue service here. If you do not see it in your recently visited tab, you can just search it on the search bar here. So let me open it, and I have a queue created here which I'm using in my application. So let's create another queue for the example. So we can create two types of queues, standard and FIFO, and you can read the description here, like what are the benefits of FIFO queue over the standard queue. And we are going to take a look at, for the sake of this demo, on the standard queue only. So let's say it is demo queue, and there is some options, like we have a lot of options, but I'm going to tell you about few options only here so that we can keep this tutorial simple. So visibility timeout is something like, for example, we have two servers here running for the receiving application, which can poll the queue for the messages, which can get the messages from the queue. So when one application has taken the message from the queue, that message will not be visible for this amount of time which we specify here to any other receiving application or receiving server who is polling the same queue. It happens so that we can avoid duplicate processing of messages. Now, when this happens, uh, that application which got this message has to process complete its processing and delete the message from the queue after its processing is done. And it should be done under the visibility timeout window, which is in our case is 30 seconds. If it fails to do so, if it is not able to process the message and process and delete the message, then this visibility timeout window gets over. Then other application which poll the queue will be able to see that message. So for SQS, it is like a application sender application has put the message into the queue, and the other applications which are getting the message from the queue have processed it and delete the message from the queue before the visibility timeout window gets over. Message retention period, like if the message has not been processed from the queue, it has not been get and not been deleted from the queue, it will be retained in the queue for this duration, which we can specify here. The maximum message size, and we can leave rest of the things for now. We have server side encryption. We can enable or disable it. I will just keep it enabled. Now it is asking me for access policy. So only the owner of the queue can send or receive messages. I do not want this. So what I'm going to do here is that only specified accounts, AWS IAM users and role can send the messages to the queue, and only specified accounts and IAM users can get the message from the queue. So you are going to create a user. So in my case, I have created a user called queue user, and I will copy the ARN and paste it here. So only this user will be able to get input messages from the queue. The owner can do everything on the queue, obviously, because he or she is the owner of the queue. Apart from it, the queue user can put or delete messages from the queue. Why? Because in our application, we are going to use the access key ID and secret access key for this user. Okay, so a policy will be created here and will be applied to the queue, and in that the queue user account will be able to get and put messages from into the queue, right? Now we can leave rest of the options as it is, and you can click on create queue, right? And then you will get a queue name along with the queue ARN. I have cancelled that because I have the similar queue created here, and this is the URL of the queue using which we are going to put and get messages from the queue. Now what we can see here is that we can send and receive to the messages from the queue. You can test it from here, like you can click send. So the message is test MSG YT for YouTube. I will send this message, and my message is sent to the queue, and it is ready to be received. So I'm going here, click on more, and if I see what are the messages available, message available in my queue are 1. So now we can go here again and poll for messages. I can see that I have 1 message here, and now I can select it and delete it. Now when it is deleted, it won't be, if we poll again, then we won't get the message here. So now poll, we are not getting that message here, right? So you can test it out here, you can play around here. Now let's come to our Express.js application. So what you're going to do, first of all, you have to install the AWS SDK client SQS for this to work, and import SQS client, send message command, receive message command, and delete message command for this example, right? So my secret access key and access key ID for AWS account is written in the config.env file, right? So I'm creating an Express application which is running on port 3000, and you are going to first create the SQS client. So we have imported SQS client from the AWS SDK, and we are going to pass the region where our queue is, and we are going to pass the credentials. Apart from it, we are going to set the queue URL, which we can get from here. So if you go to your queue, you can see a URL here, right? And then you paste it here. Now, for the sake of this example, consider this route app.post route on message, right? Consider this as one application, which is the sending application, and consider this as the receiving application, right? As another application, the get method on the same endpoint, right? So if there is these are different applications for you, or different microservices application, then what you're going to do, like from one application you can put messages and from the other you can receive them. So how to put message in the queue? So first of all, you're going to create a message body. You can put any type of message, it has to be textual message. So I have created a object which is called message body, and I have put my name, age, and occupation here, and I have stringified it because we can store only text in our queue, right? And then we have some parameters which we are going to pass to the send message command, receive message command, or delete message command according to the operation we are performing. So I'm passing the queue URL and the message body. The key have to be exactly same. Now we are going to uh, await SQS client dot send new. We are going to create a new instance of send message command and pass these parameters to it, which is the queue URL and the message body. Once that is done, it is going to return us a few things, and the return response we are going to store in data. And in data, we have a field called message ID, which is going to be unique for this message. And then we are going to send a response that we have put the message into the queue successfully. If we have some error, we are going to see the error here, right? And our application consider this endpoint as a receiver application. So when we hit the get route on the same endpoint, we are going to get the message and delete it. Let's read the code. So in the parameters, we are passing the queue URL. So these parameters are for getting the message from the queue, right? So the queue URL and the number of messages we want to retrieve from the queue. So we are going to get one message only as of now for this example. So we are going to await the SQS client dot send new. We are going to create a new instance of receive message command, and we are going to pass these parameters. If there are any messages in the queue and the length is greater than 0, then we are going to store the from the array of the message the 0th message into the message object, and then we can log it to the console, or we can send it as a response as well. So now once we have received the message, we can do our application logic here. Whatever application our receiving application wants to do, it can be done here. Receiving application logic. And once the receiving application has done its task, right, then they have to delete the message. Otherwise, after the visibility timeout window is over, if you do not delete the message, it will be visible to other applications, other receiving application. If multiple receiving applications are running, then it will be going to visible. It is going to be visible to them as well. Then we have the delete parameters, queue URL, and in the message, whatever message we receive, in that message, apart from message body, we have a receipt handle, and this receipt handle is unique to every message, and we are going to pass this receipt handle as the delete parameters, as a field to the delete parameters object. Then we are going to await the SQS client dot send new instance of delete message command, and we are going to pass the delete parameters. So we are going to finally send a response to the client that message has been received and deleted from the queue. Otherwise, we are going to send a message that no messages in the queue. If there are no messages in the queue, then the else block will run. If we have some error, then our error will be sent to the user, whatever error is received. Now this is the our server which we are going to run on port number 3000, which is defined here. So let's go to Postman to see the example. So here we are. We're going to put a message into the queue. So I have defined a message in my code already, right? So the message is here. If we are going to send a message dynamically, then we can send it from here, and we can receive the message from rec.body.message. So I have already have the message here, so I'm going to just post it. And now we got a response that message is sent to queue, and this is the message ID. So that was our application one, to send the message, the sender application. Now consider that this endpoint, if we get it, if we do a get HTTP request on it, then we are going to, this is our application which is getting the message and processing them. Let's get the message, and we can see that message received and deleted, and the name was name Junaid Khan, age 26, and occupation engineer. So this is the data which was put in. This is the message which was put into the queue. If we get again, we are going to see no messages in the queue because we have get it and deleted it. Now let me post the message again, and now we are going to see the message on the AWS console. So now let's go to send and receive messages, and let's poll for messages, and we can see one message is here. If I open it, I can see the body, the name which we are sending from the Node.js application, right? So these are all the things that we can do using the Amazon Simple Queue service.